Hello guys, how are you all? I hope you all are doing well. Welcome to yet another video on our channel. So we have started lecture series on complete lecture series on partial or differential equation. So welcome to you all yet another time to complete lecture series on 12th HSC board previous year question papers. So already we have uploaded plenty of the videos on our channel. So if you are interested to see this video, you may check it into our playlist. So here in our today's video, we are going to learn some of the examples from previous year board question papers, okay, which based on the basic differentiation. But before I start my today's lecture, I would like to explain some of the basic concepts here, okay. So let's get started our today's lecture. I will explain some of the concept first of all, and then we'll go for the some example which is from the previous year question paper. Now, so here before I start, just let it take a little bit time. Now here it is okay. So in my today's lecture, here we'll go for the some of the basic concepts which are important for our differential examples, okay. So first of all, we have to understand the meaning for differentiation, okay. Differentiation, it is the rate of a change in some certain quantity, okay. So this rate of a change we have to learn here in our differentiation chapter. Okay, so in our differentiation chapter mainly we included these many topics. First, it's a derivative of a composite function. Second, derivative of inverse function, derivative of implicit function, geometrical meaning of differentiation, logarithmic differentiation, derivative of a parametric function, and higher order derivative. These are the derivatives, standard form of derivatives, and these topics are needed here for our today's lecture examples, okay. So what we do first, we go for the little recap of the these topics, and after that we go for some of the examples from our board exam previous year question papers, okay. So this is only recap video that you all have to be ready in a few days, so that's why we are taking these videos here, okay. So here first, derivative of a composite function. Let me explain what is meant by composite function. Whenever we have the function like x and y, they are coming together, okay, or function of x with respect to function of x, that means composite function, it says that if I consider f of x which is equal to 2xy, okay. So I consider f of x which is equal to 2xy, 2x square y, consider it is, okay. So composite function, it says that differentiate our function first, and we have to differentiate it till end, till our variable get vanishes, okay. So f dash of x means d by dx of f of x, okay, which is equal to 2x square of x, okay. That means d by dx of 2 times x square of y, okay. So we have to take a regular differentiation, but we have to differentiate till that x variable get vanishes here, okay. So d by dx of 2x square y, what will get here? 2 constant as it is, x square it is having differentiation 2x, and y keep as it is, okay. So we want the differentiation for y also, because this is the two different function, we have to apply by part rule. So next, plus x square, it will be remain same, and dy by dx, okay. Okay, so that means here we have also dx by dx, we are differentiating that x till that x get vanishes, okay. So dx by dx having value 1, so we are not taking this one. So composite function, it says that it comes function under function, so we have to differentiate that function till our variable get vanishes, okay. That's it only for our composite function. Now let's go for the inverse function. You all need to understand the derivative for inverse function. What is mean by inverse function? Whenever we get the inverse image of any function, okay. So for example, inverse function means if we have function sin x, okay, I consider here f of x as sin x, okay, f of x as sin x I consider here, and its inverse function means which is given, okay, f of x which is equal to sine inverse of x, which is equal to f of x, okay. So that means the image from domain to codomain or pre-image from codomain to domain, it consider as the inverse of our given function. Okay, so you all have to understand the meaning for inverse of a function. Okay, so so we are going to learn all this inverse function for our differentiation. Okay, so it is not only with the sine inverse. So we are having some another inverse function like a cos inverse, tan inverse, cosec, sec, cot, all type of the inverse function. And these all functions are having some standard results, so we all have to remember these results. Okay, so even though it is having some standard process for finding its differentiation, that we consider as a first principle for differentiation. Okay, we'll go what is mean by first principle. Whenever we want the differentiation of any function f dash of x, we take limit as h tends to 0 f of x plus h minus f of x completely divided by h. Okay, so this is considered as first principle for our differentiation. Okay, okay, so by using this one we can find the any type of a differentiation. But in most of the case, what happen for finding the differentiation using first principle, it is quite lengthy and time taking. So in our board exam, we don't have enough time to use this one. Okay, this result. So in such a case, what we do, we apply directly standard result for finding its a differentiation. Okay, so it is a time saving and to get the quick and easy answer. Okay, so here it is only for the inverse function. So implicit function, okay, differentiation of implicit function, that means if we have x and y variable together, we have to differentiate y2 also. Okay, so x which is equal to y, if I consider this function here. Okay, so differentiation of dx by dx, which gives us 1. Okay, and here differentiation of y, it comes dy by dx. Okay, so that means we have to differentiate our y variable 2 with respect to x, like a dy by dx. It is a differentiation. We consider this one as a differentiation of implicit function. Okay, and now let's move for the higher order. I just wanted to recap all these topics here. Okay, because we don't have enough time to go for all of them, so this is the only recap video you all need to understand. So if you wanted to see more videos like detailed videos on this topic, recommend me and request me in a comment section. Okay, I will come up with the videos on these topics. Okay, separate videos. Now here derivative of higher order derivatives. Okay, so what is mean by higher order derivative? That means whenever we have function, it gives a first derivative f dash of x, second derivative f double dash of x, third derivative f triple dash of x. That means the differentiation of a single function, it is 1 time, 2 times, 3 times, or more than 3 times. We consider it as the higher order derivative of our function. Okay, so consider here, if I consider f of x is a function. Okay, so first derivative we write d by dx of f of x. Okay, second derivative we write as a d square by dx square of f of x. Okay, this one is the second derivative. So we write a third derivative d cube by dx cube of f of x. Okay, so these are the higher order derivatives. That means these derivatives are getting higher and higher their order. Okay, so we have to differentiate same function once, twice, thrice, and so on. Okay, so we consider this one is the higher order derivative. After that, geometrical meaning of a differentiation. Okay, so using this topic, we have to take some of the geometrical concept here, like a tangent, like a secant. Okay, so we consider under it is application of a differentiation. Okay, so we need to understand tangent, secant, and their rate of a change. Okay, so whenever our curve is having tangent, okay, it is having tangent and that tangent touches to our curve at a single point, we consider that function is a differentiable. Okay, so if touches more than 2 points or not touching our curve, so our function it is not differentiable. Okay, this is the geometrical meaning. Okay, geometrical meaning contain vast number of topic, vast number of concept, so we don't have enough time for this one. So if you wanted to see this video, you may check in our playlist. Okay, these topics also there. Okay, so after that, logarithmic differentiation. Logarithmic differentiation means when we use logarithmic differentiation, whenever we have function under function like f of x, g of x, or f of x to the power g of x plus h of x. Okay, so function to the power function, function under function, multiplicand of a function, function divided by function. In this case we apply logarithmic differentiation. Okay, what is the speciality here for logarithmic differentiation? We apply some of the rules, okay, from logarithm chapter for finding our differentiation. Okay, so mainly this rule we consider here. First rule as exponent rule. Okay, exponent rule. Okay, exponent rule, what it is says that whenever we have a to the power x, after applying log to the a to the power x, what it does, log of a to the power x, we take that x up from here, x into log of a. Okay, so this one is the exponent rule for logarithm. Okay, after that we have logarithmic rule for addition, subtraction, okay, multiplication and division. Okay, so whenever we have log of a divided by b, we write log of a minus log of b. Okay, so this one is important here. That second rule we are going to apply for our differentiation. And third rule we take as a log of a multiplied by b. Okay, so we write log of a plus log of b. These rules are very much important for finding our differentiation. Okay, so whenever we have some complicated type of the example like a log of a into b, and a and b are complicated type of the functions. Okay, so in such a case it is quite difficult to apply the rule. Okay, rule by part rule for our differentiation. Now in such a case what we do, we take some of the results from logarithm chapters. Okay, just only 3 to 4 results are important. Okay, I hope you all have understood all this part. Okay, and a derivative of a parametric function. Okay, just let me recap with only 2 or 3 words. A derivative of parametric function means whenever we have a function with respect to function. Okay, till now we learn differentiation of function with respect to x, differentiation of function with respect to y, but now in this case what we have, differentiation of f of x with respect to g of x, differentiation of f of x with respect to h of x. Okay, that means differentiation of a function with respect to function. In such a case we have to apply a differentiation of parametric function. Okay, so here it is the derivative of a parametric function. It contains the meaning. Okay, so I hope you all have understood all this recap for all these topics. Okay, so even after, if you found anything difficult, let me know, okay, in my comment section. Okay, let's go for the next slide. So we go for some of the example now. Yeah, here I have taken some examples from previous year board exam. Okay, these are very much important examples, as board exam it is coming near and near. So what we have to do, we have to solve most of the previous year question, that at least you will get an idea how can we solve the question in a short time. Okay, you have very much short time to attend your questions. Okay, so let's get start our first question. Our question second, it says that if we have function y which is equal to sec of root x, then we want the dy by dx. Okay, so we have y which is equal to sec of root x. Okay, what we have given, y which is equal to sec of root x which is given. Okay, and we want the value for dy divided by dx. Okay, that means our function which is in the form of x. Okay, y is a function in the form of x. That means we have to differentiate our y with respect to x. Okay, so which is a dy by dx. Now differentiation of y with respect to x, what we will get, dy by dx. Okay, now see that we can differentiate that function using first principle also, but now in this case to apply first principle it will be time taking, so directly we have to apply the differentiation of a sec of x. Okay, so differentiation of a sec of x, it will be the sec into tan. Okay, that you need to know. Okay, so what we have here, function under function. Okay, like a composite function type of the differentiation here. Okay, dy by dx, that means d by dx of sec of root x, d by dx of a sec of a root x. Now we can see that function under function, that means under trigonometric function we got the polynomial function or algebraic function. Okay, whenever we have function under function, we have to apply composite type of the differentiation. Okay, so we know that first form here, differentiation of sec x. Okay, different d by dx of sec x. Sec x, you need to note the differentiation of sec x, which is a sec x into tan x. Okay, you need to know this differentiation. Okay, now apply regular differentiation as we do. Okay, as we did in our past lectures. Okay, the differentiation of sec of x will be sec of x into tan of x. Okay, sec of x into tan of x, and after that we differentiate that root x further. Okay, so that means d by dx of root of x. Okay, so this one it will remain same, and we have to differentiation of d by dx of root x. Okay, so this is the composite type of the differentiation. So composite type of differentiation, differentiate that root x further, so the step it remains same, sec of root x into tan of root x, and differentiation of a root x is which will be the 1/2 times root x. Okay, so 1/2 times root x. Okay, and at the end we differentiate that x with respect to x. Okay, so that means it gives the value 1. So our required answer it is here sec of root x tan of root x and multiplied by 1/2 times root x. Okay, that means 2 times root x here. This is our required answer. Now see that what it is difficult here, nothing, just we applied some of the basic result, that means one result from sec x. Okay, directly we land on our required answer. Okay, I don't think so is anything difficult here. If you all can know these the results, standard results, that it is a differentiation very much easier. Okay, so that question asked for 3 marks in a July 2016 board exam. Okay, 3 marks for July 2016 board exam. So see that its answer is in only 2 to 3 steps. Okay, I hope you all have understood. Let's move for the next example. Yeah, so here we have next example. If y given tan square log of x cube, find dy by dx. Okay, now see that function under function, function to the power function, that means these are the composite type of differentiation. Okay, composite type of a differentiation. Then we want the value for dy by dx. That question asked in March 2018 for 3 marks. Okay, these are the very much easier example. We have to grab this example. Okay, these examples helps us to make score high in our board exam. Okay, so make sure that always solve this example first. Okay, so we have y which is equal to tan square of log of x cube. Okay, so we have given function y is equal to tan square of log of x cube. Okay, and we want the differentiation for this one. Now apply a regular differentiation. We know that differentiation of a tan square of x. Okay, so n x raised to n minus 1 apply there. Okay, so differentiation of a tan square x means apply differentiation of both sides. We want the dy by dx. Okay, dy by dx, differentiate our function with respect to x. Okay, so which is a dy by dx, and d by dx of differentiate another side, tan square of log of x cube. Okay, tan square of log of x cube. Okay, so here we have differentiation with respect to x of this function. So what we do, function under function, that means for tan square of x is given, so apply differentiation of a d by dx of x to the power n. Okay, so d by dx of x to the power n, which gives n x to the power n minus 1. Okay, differentiation of x to the power n, which is the n x to the power n minus 1. So tan square of x, that means 2 tans to the power 2 minus 1 of a log x cube. Okay, so apply this one. So function which is a composite type of function, so that differentiation will be continue till it get vanished. Okay, so tan square of x, which will be the 2 tan square, that means it goes to the 1 to minus 1. Okay, 2 tan of log of x cube. Okay, to tan of log of x cube. So we have taken differentiation with respect to that tan. Okay, now differentiate that tan of log of x cube, which gives us differentiation of tan of x, which is a sec square x. Okay, sec square and x. Okay, x value for x, which is a log of x cube, which is a log of x cube. Okay, so differentiation nx to the power n minus 1. After that, differentiation of tan x here, which is a sec square of x. And now after that, you have to differentiation d by dx of under this function, which is a log of x to the power 3. Okay, log of x to the power 3. So you can take that 3 front here as using exponent rule for a logarithm. Okay, so what we will get the next step? 2 tan of log of x cube, okay, multiplied by sec square of log of x cube. Okay, which multiplication is a log of x cube. Okay, that means 3 comes out here by using exponent rule of a logarithm. Log x which having differentiation 1 upon x. Okay, so this is our required dy by dx. Okay, this is the value for our required dy by dx. Okay, so this our final answer. If you have possible for finding next steps here, that means multiply 2 into 3, it gives us 6. Tan of log of x cube, sec square log of x cube divided by x. Okay, so how can we write next step here? So here we can see 3 into 2, we get the 6. After that, tan of log of x cube, tan of log of x cube, okay, tan of log of x cube into multiplied by sec square of log of x cube. Okay, and completely which divisible by 1 upon x. Okay, so this is our dy by dx, required dy by dx. Okay, this is our required answer. I hope you all have understood our solution for this example. Okay, this example asks for 3 marks in March 2018 question paper. Okay, so see that how easy questions are these. These questions gives us very easy marks in our example. Okay, so make sure that attempt this question first. Okay, I hope you all have understood this one. Now let's move for the next question. Yeah, we have the next question, which is the differentiation of a sine of x square plus x with respect to x. Okay, we want the differentiation for what? Sine of x square plus x with respect to x. A question asked in February 2020 for 3 marks for in February 2020 exam. Now see that these questions are latest question from our previous board exam question paper. So our function is here y, which is equal to sine of x square plus x. Okay, sine of x square plus x which is given. Okay, and we have to differentiate with respect to x. That means we want the value for dy by dx. Okay, what we want? We want the value for dy by dx here. Okay, so find out dy by dx. That means differentiation with respect to x, dy by dx. Okay, now see that function which is a composite type of a differentiation. That means we have to differentiate it till inside function get vanished. Okay, so d by dx of sine of x square plus x. Okay, d by dx of sine of x square plus x. Now differentiation of sine x, which will be the sine is having differentiation cos, and cos which is having differentiation minus sine. Okay, this basic formula you need to be familiar with. Okay, so sine of x having differentiation cos of x square plus x. Okay, now function which is a composite type of the differentiation that x square of x square plus x, after that d by dx of x square plus x. Okay, so that means function under function, so differentiate that function later on also. Okay, okay, so cos of x square plus x, it remain as it is. Now differentiation of x square, that means 2x into dx by dx, which is 1, plus dx by dx, which is 1. Okay, so our required answer, which is a dy by dx, which is equal to cos of x square plus x into 2x plus 1. Okay, this is our required final answer. Now see that only in a 3 steps the answers are coming. Okay, now see that how easy it is to score in our board exam. Okay, I hope you all have understood this example. Okay, so even if you found anything difficult, let me know in comment section. Okay, now let's move for the next example. Okay, our next example, differentiation of a log of sec x plus tan x with respect to x. Question asked in February 2020 board exam. Okay, for 3 marks in February 2020 board exam. Okay, okay, now let's start the solution, which is a very much easy solution here. Okay, now function, we want the we have given function. Okay, always remember that consider our function as a y, which is equal to log of sec x plus tan of x. Okay, okay, and we have to differentiate with respect to x. That means we want the value for dy by dx. Okay, so first of all you need to understand what we have given and what we have to find. Okay, then answers are quite easy after this. So here y is equal to log of sec x plus tan x. Now find out its a differentiation, dy by dx, which is equal to d by dx of log of sec x plus tan x. Okay, now we want the differentiation of a sec x plus tan x. Now we can see here log of sec x plus tan x means function under function which is given. Okay, function under function, that means it is a composite type of a differentiation. Okay, so apply the composite rule for differentiation. So log of x, consider this whole bracket as x. Okay, so log of x having differentiation 1 upon x. Okay, that means 1 upon x is having value sec x plus tan x. Okay, sec x plus tan x 1 upon x. Okay, having differentiation after this. Okay, multiplied by differentiation of d by dx of sec x plus tan x. Okay, so we have to differentiate that x further till it get vanished. Okay, so 1 upon sec x plus tan x, keep as it is here. Differentiation of a sec x, which will be the sec into tan. Okay, sec x is having differentiation sec x into tan x, plus tan x is having differentiation sec square x. Okay, okay, tan x having differentiation sec square, and sec x having differentiation sec x into tan x. Okay, now take the sec x into sec x common from here. So next step we'll get sec x common from both of the term. So under bracket tan x plus sec x remain. Okay, tan x plus sec x under bracket it is remaining here, and completely divided by, we have denominator sec x plus tan x, sec x plus tan x. Okay, now we can see that sec x plus tan x, sec x plus tan x get cancelled, so we remain here sec of x. Okay, this is our required answer. Now see that how easy this type of the questions are. Okay, just only in a 3 to 4 steps we are getting the answers. Okay, I hope you all have understood this complete example. Okay, which asked for February 2020 exam. Okay, all are the latest questions. Okay, that you all need to know how and which type of the questions are coming in our board exam. Okay, now let's move for the one more example. So see that we have next function y, which is equal to tan inverse of 8x upon 1 minus 15x square. Okay, and we want the value for dy by dx. Okay, question asked in July 2020 board exam for 4 marks. Okay, question asked for 4 marks in our July 2020 board exam. Okay, so our function, it says that y, which is equal to tan inverse of 8x upon 1 minus 15 x square. Okay, so we have the value for y, which is equal to tan inverse of 8x upon 1 minus 15 x square. Okay, now see that our function, which is 8x upon 1 minus 15 x square, it is there. Okay, now we have to expand this result first. Okay, in most of the situation, what happen, the differentiation of a directly function, it is quite much confusing. So before solving our differentiation, we have to apply some of the trigonometrical concept that can be helpful for our differentiation. Okay, so here we apply tan inverse of a plus b. Okay, so we apply the result we will apply the some result for which contain tan inverse of a plus b. Okay, so tan inverse of a plus tan inverse of b, we write it as the tan inverse of a plus tan inverse of b can be written as, okay, tan inverse of a plus b upon 1 minus ab, tan inverse of a plus b upon 1 minus a multiplied by b. Okay, this is the expansion for tan inverse of a plus tan inverse of b, which is the tan inverse of a plus b upon 1 minus a into b. Okay, now see that our this result and this one we can compare together. Okay, so once we compare this both form, okay, then we can expand it from here. Okay, and after this differentiation tan inverse of x is equal to 1 upon 1 plus x. Okay, so we apply this result here. Okay, differentiation of a tan inverse of x, which is a 1 upon 1 plus x square. Okay, and now see that in our next part we convert this result in this form. Okay, tan inverse of a plus b upon 1 minus ab. Okay, so we can write 15 as a 5 multiplied by 3. Okay, and 8 as a 5x plus 3x. So we can write this one, okay, y which is equal to tan inverse of 8x can be written as a 5x plus 3x. Okay, 8x I have written 5x into 3x. Okay, 1 minus 15x square can be written as 5x multiplied by 3x. Okay, a multiplied by b, 5x multiplied by 3x. So 5x into 3x, it goes to the 15x square. Okay, so this is the value for y which I found here. Okay, so tan inverse of a plus b upon 1 minus ab. So we write it as the y which is equal to tan inverse of a plus tan inverse of b. Okay, tan inverse of a, that means tan inverse of 5x plus tan inverse of 3x. Okay, so we write it as the tan inverse of 5x plus tan inverse of 3x. So one more standard result we have to consider here for our differentiation, d by dx of tan inverse of x. Okay, so we write this one as a 1 upon 1 plus x square. Okay, this is the differentiation of a tan inverse of x, which is a 1 upon 1 plus x square. Okay, so we are going to apply this result here for finding our differentiation. Okay, so tan inverse of x, which is a 5x. Okay, so differentiate both of the sides, we'll get here, differentiate both the sides here. Okay, so dy by dx, which is equal to d by dx of tan inverse of 5x. Okay, plus d by dx of tan inverse of 3x. Okay, so differentiate both of the terms separately. So we'll get the tan inverse of x is having differentiation 1 upon 1 plus x square. So 1 upon 1 plus 5x bracket square into differentiation of that x further here. Okay, multiplied by differentiation of 5x, which is the 5. Okay, okay, plus this is the complete differentiation for this term. So here also 1 upon 1 plus 3x bracket square. Okay, and into differentiation of 3x, it gives only 3. Okay, okay, now what is the next final term? We get it here, dy by dx, which is equal to 5 upon 1 plus 25, 5 5s are 25 x square. Okay, so what I have done, I taken the square here for the term of 5 plus 3 upon 1 plus 9x square. Okay, so this is our required answer for our given question. Now see that only in 4 steps we are getting the answers. Okay, so that question asked in July 2020 board exam, that means it's previous year questions. How easy these types of the questions. Okay, so you don't have to lose these marks. First of all, grab these marks first, solve this question first, and then move for the remaining question. Okay, this type of the question you have to attempt in your board exam first. Okay, so I don't think so is anything difficult in our example number 7 here. Okay, so even if you found anything difficult, let me know in a comment section. Okay, I will come up with the similar videos. Okay, this is the complete solution. So if you wanted to see this solution, I will post this written solution in my comment box. Okay, now let's go for the little recap. Okay, complete review what we have learned in our today's lecture. Okay, So first we'll started learning about first the differentiation topic. Okay, differentiation topic. Okay, so I explained here with the first principle. Okay, I explained differentiation topic with the first principle. Now secondly, okay, after first principle, for that differentiation topic, we explained here the composite function. Composite function. Okay, composite function, that means function under function. Okay, after that, different type of the differentiation, different type of differentiation. Okay, different type of the differentiation mean logarithmic differentiation, parametric differentiation, implicit function differentiation. Okay, this topic we recapped here. Okay, and after that, geometrical meaning, that means in single word we learn here a little recap about the rate of a change of a quantity in a geometrical concepts. Okay, so all these concepts we have learned here in our today's lectures. Okay, even if you found anything difficult, let me know in my comment section. I will come up with the same type of the videos in our channel. Okay, so if you are interested to see these more videos, you may check it into my playlist. Similar videos are there. So thank you everyone. Thank you for my today's lecture.